This video is about review for final. Question 1. Jean starts reading a book on the 1st of February. The number of pages she reads each day increases by the same number on each successive day. Calculate the number of pages Jean reads on the 13th of February. First of all, according to increases by the same number, we know this is an arithmetic sequence. We are about to use this formula to figure out this problem. On the 13th of February, which means U sub 13 equals. Using this formula, we will get U sub 1 plus 12D. We know that D equals U sub n minus U sub n minus 1, which means U sub 2 minus U sub 1. According to this table, we know U sub 1 equals 8 and U sub 2 equals 13. So 13 minus 8 equals 5. Then we can plug in 8 plus 12 times 5. That equals 68. Let's go to B. Find the exact total number of pages Jean reads in the 28 days of February. Basically, we are looking for S sub 28. We will use this formula. That equals 28 over 2. Then 2 times U sub 1 is 8. Then plus 28 minus 1 is 27. Times D is 5. So G can read 2,114 pages in the 28 days of February. Let's go to question 2. The amount of water W in liters remaining in a cooking pot after it's placed onto a hot stove is given by the function. W of T equals 30 times 0.72 to the T's power T greater than 0, where T is the time in hours after the pot is placed on the stove. Find the initial amount of water in the pot and the percentage of water that leaves the pot in the form of steam each hour. When you say this kind of a function, W of T is like f of x. F of x equals y. So when you say this, you can think about the function W equals 30 times 0.72 to the T's power. Do not think W of T is W times T. W of T is a function notation. When you say initial, which means T equals 0. So for A, 30 times 0.72 to the 0 power. Any number to the 0 power equals 1. So we have 30 liters. This is the initial water. We will use WO stand for that. Second one, the percentage of water that leaves the pot in the form of steam each hour. First of all, check this function. This function is the amount of water remaining in a cooking pot, which means 72% of water remains in a cooking pot each hour. So the percentage of water that leaves the pot will be 1 minus 0.72. That is 0.28 equals 28%. For B, calculate the amount of water remaining in the pot after 5.5 hours. So for this W equals 30 times 0.72 to the 5.5 power. Answer will be 4.93 as a 3-sig fix. So answer is 4.93 liters after 5.5 hours. Look at the C. Find the number of hours that has passed when there is 10 liters of water remaining in the pot. Now we use this function. The remaining water is 10 equals 30 times 0.72 to the tth power. We want to use the equation solver to solve this equation. So move this to the left side. 10 minus 30 times 0.72 to the tth power equals 0 by solver. Let's go to y1. 10 minus 30 times 0.72 to the x power. Then math solver. Alpha trace y1, enter. Let's estimate as 5. Alpha, enter. So the answer will be 3.34 as a 3-sig fix. T equals 3.34 hours. Let's go to question 3. The lifetime in thousands of hours of LED bulbs at a manufacturer plant were recorded for a periodic quality check. The data is illustrated in the box and whisker diagram shown below. Write down the median lifetime of these LED bulbs. For the box and whisker diagram, we know this is a minimum, the lower quartile, median, upper quartile, and a maximum value. So the median, that will be 40,000 of hours. B, write down the range. The range equals the maximum minus the minimum. Maximum is 43. For minimum, you could say between 37 and 38. There are 4 small units, which means each unit is 0.25. Therefore, for this will be 37.75. That's the minimum value, 37.75. So answer is 5.25 thousand hours. Let's go to C. Find the interquartile range. Interquartile range equals the upper quartile minus the lower quartile. The upper quartile, check here. This is 41.5. The lower quartile is 39.25. So we have 41.5 minus 39.25. We will get 1.25 thousand of hours. Let's go to D. Find the shortest and the longest lifetime of an LED bulb that is still not considered an outlier. We know the lower outlier equals Q1 minus 1.5 interquartile range. So we plug in. That is 39.25 minus 1.5 times the interquartile range is 1.25. Answer is 37.375. For the higher outlier, the upper quartile plus 1.5 times the interquartile range, that equals 41.5 plus 1.5 times 1.25, 43.375. Suppose the manufacturer plant is making 100 LED bulbs. Write down the number of LED bulbs whose lifetime will be between 39.25 and 41.5. Basically, it's here. 50% of the total number equals 50. F, between 41.5 and 43. 41.5 and 43 will be from here to here. This will be 25% of the data. So 25% times 100 will be 25. Remember for the box and a whisker diagram. In this box will be 50% of data. This is 25% of data. From lower quartile to median, this is 25%. From median to the upper quartile will be 25% data. Let's go to question 4. Tom takes out a loan of $70,000 to purchase new machinery for his farming business. He agrees to pay the bank $1,100 at the end of every month to amortize the loan. Interest accumulates on the balance at a rate of 5.75% per year, compounded monthly. Find the number of years and months it takes to pay back the loan. We got to use TVM solver. So let's draw the table. We are looking for number of years and months. So this is a question mark. Interest is 5.75. Present value, that is positive 70,000. PMT is negative 1,100. Future value will be 0. This is 12, here is 12, because this is monthly. So for this N will be the years times 12. Let's go to calculator. So we put this value in, then alpha enter. N will be 76.091517. Remember, we need to divide it by 12 to figure out the years. So the years will be 76.0915 divided by 12. So we get 6.35 years. Since 0.35 times 12, that is 4.2 months. We need to round this 4.2 up. So we get 6 years and 5 months. Let's go to B. Calculate the total amount that Tom pays in amortizing the loan. Monthly payment is $1,100 times 6.35. Then times 12, $83,820. Let's go to C. Tom decides to increase the monthly payment to $1,400. How much interest will Tom save in comparison to the former payment schedule? So for PMT will be negative 1400. We still look for this N. We will change this PMT is negative 1400. So we go to this N, alpha, enter, 57.3. We get this is 57.3. We will use this dollars, total payment, minus 57.3 times 1400 to figure out how much interest Tom will save. We'll save $3,600. For this 57.3, basically it's years times 12. That's the reason we just use 57.3 times PMT, means the total money paid by Tom.